Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at photometrics options and printing panel schedules to HTML options for Design Master Electrical. If you are attending the training live, you can ask questions in the chat box. If you are watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497. And our email address is support@designmaster.biz. So we're finishing up looking at all of the options in Design Master Electrical today. We are going to be looking way down at the bottom at the printing panel schedules to HTML and also at these photometric options. So we'll start by looking at the photometric options here. The first option there is copy IES files to project folder. So when you're working with photometrics, the IES files are an important part of that. That's where we get all the information for doing the calculations. And typically you have those files saved somewhere on your file servers. People typically build up libraries of those. And we actually copy them to the project folder so that your project folder has the IES files that were used, so you can have a complete set of data. So if you ever need to recreate it, if your network structure gets messed up, the IES files aren't lost. The IES files are pretty small, so it's not a very big deal to have them in there. So by default, we do copy them there. We have the option to turn that off if you don't want to copy them there for whatever reason. We can still find them on the network. Just to show you what that looks like. So here's an IES file. And you'll see it's only 4 kilobytes, so they're pretty small, so it doesn't really matter if you copy them in there. So that's what that does. So those get copied when you assign the IES file in the light fixture schedule. So when you run the light fixture project schedule command, and you select an IES file, that's the point at which if the IES file was somewhere else, it would be copied into the project folder. Next option is to show foot candle levels when printing the point by point on the drawing. There's also showing the contours, whether we're going to display those, and then the decimal spaces. Those are all actually set also when you run the calculation. This is basically a way to set the defaults for future projects. So when you run the calculation, you get those same choices. It's basically these 4 options up here. A checkbox for whether we're showing foot candle levels, showing the contours, and then the number of decimal places we show on the drawing and the schedule. So we can make those changes when we do the calculation, and then you can also set it in the options for future projects. So right now, if we uncheck the show foot candle levels and run the calculation, it'll do just the contours. Alternatively, we can turn the contours off and show just the foot candle levels. We also have the options there for the decimals, and that controls the precision shown on the drawing and then in the schedule. So on the drawing will display the value, the decimal points here, and then the schedule will display them here. We have the option there to display more just because the schedule, you'll get your uniformity ratios, and you're dividing numbers, and so you want a little bit more precision sometimes to be displayed. So we have the different options for those 2 different locations. So we could add additional precision if we wanted to. Those are normally set when you're running the calculations, and the reason we have them in the options again is mostly so that you can set it in your standards so that future projects are set up properly. Base unit and reflections are also the same thing. They're normally set when doing the calculations, so you can set your base unit to either an inch or a foot, and so that's whether your drawing has a base unit as an inch or a foot. If it's an inch, that's most architectural drawings are that way. Some site plans have a base unit of a foot. So if you are working outdoors and the calculations aren't coming in right, you can adjust this, and then you can have a foot as the base unit. And then reflections as to whether you're going to do reflections of the light off the wall or not. It does add to the calculation time, so that's why we don't always do the reflections, and you can choose whether you're going to turn that on or off. The default grid spacing, when you insert a new calculation area, we'll fill in the grid spacing there. So if I can find my command and insert a new area, that sets the default value here. So if you want to have a default, just that filled in with a different value. Default, our original default is 10, but you could have it something else. This can be changed once you put it in, but that way, if you're always changing it, you can have it set to something that matches what you use more frequently. Then the final options we have are the contour foot candle levels and the contour layers. So we have the setting here for the foot candle level at which we're going to draw the contour. So this is currently set to 5, 2, and 1. We could add another one here at, say, 10 foot candles. And then we can also set the color or the layer. So you can actually have different colors for your contours. So I'll just start by just setting them to a color. Turn the contours back on. You see it filled in the values here. So basically, again, we're setting the values through the options that are also available in this dialog box. And it fills it in with all of the contours and their colors. We recently added an option for the contours. Previously, you could set the color. Now you can also set them to a specific layer. So the layer has to be defined in AutoCAD. It doesn't go through our normal layer, so it assumes that you've got the layer defined, but then you can assign it to a different layer if you want to. So that if you have a different layer for each contour, where maybe you've got the different line type assigned to it, with the foot candle level, you could assign that layer here. And to do that, you just type in the layer. We'll put in a test layer for contour number, well, actually I'm going to do it for contour number 2, because that one's actually used. And then we can adjust it here. And so now it's going to use this layer when it uses that contour. So those are the options for Photometrics. It's mostly to be able to set the defaults for this dialog box in your options so that future projects are already set up and ready to go. The other options we're going to look at are the print panel schedules to HTML. And this, for the most part, is the same idea as the Photometrics, where it's just setting the values that you could otherwise set in the software. So we have the command to print your panel schedules. And so all of the options are controlling basically this right-hand side. So all of these settings you can set to get the panel schedule to print how you like. You can set them up in options and then save it for future projects. So I'll leave all the defaults here as they are. And it creates them. It basically creates them in an HTML file, and then you can print that out to a piece of paper on your printer, and then actually put these on your panels. These are intended for actually labeling the panels in the field. So they're kind of a stripped down version of the panel schedule. And so you have the various options as to what you want to include in the header, what you want to include for the circuits, whether you want to have the load in KVA or VA, if you want to have the breaker size or the description in there. So you have all of those options, and those can be controlled in the options command. And that is it for today for the options. Those 2 sections are not the most interesting, but for completeness, I did want to cover them. If you have any questions today, feel free to let me know in the chat. I also have a couple questions that came in through support over the last month that I thought would be interesting to talk about. So I'm going to go ahead and pull those up. And if you do have questions, just put them in the chat and I'll get to those while I'm also going through these emails that I have. The first one, there's actually 2 emails relating to residential multifamily dwelling calculations and how to get everything set up right. In particular, how to handle the lighting loads. And the lighting loads are a little bit different, so it does require some setup to get them to work properly. So I'm going to go ahead and go to a blank spot here. I'm going to create a new panel. And we'll go to our feeder and service calculation settings. And for our load calculation method, we are going to go to a dwelling unit. So this is using the optional calculation from the NEC 220.82, where you've got some different options for your dwelling unit. And actually, this what we're going to do applies to just general dwelling units and all the others. So actually, it doesn't really matter what load calculation method we choose, because the concept here is actually the same for all of them. So we're going to put in our lighting load. And so lighting for the dwelling units is going to be based on the area for the general lighting. So we'll say that this is a dwelling unit. It's a 1,000 square foot apartment. And we do want to change the demand factor from a continuous load at 100% to a dwelling unit. And then it'll use the 220.42 demand factors for the lighting, or it'll see that it's actually a dwelling unit load, and it shows up as a dwelling unit light. So we'll change that to dwelling units. And now I can insert my panel schedule. So we've got the 1,000 square feet at 3 watts per square foot. So we've got 3 kVA of load on this panel. Now, this is where people always have trouble. You want to add, say, some receptacles. So you've got some receptacles in, just anywhere in the dwelling unit, really. And you're going to add them to your model. I'm just going to type these in. Normally you'd have them and you'd circuit them. But we'll just do this with fixed loads. And so the question is, what load type should you use for the receptacles? We don't actually have, because the receptacles are general lighting, so they actually fall under that 3 watts per square foot. There really isn't a good spot to put them, so you can put them in your receptacle, and that's probably the best spot just because they are a receptacle, but this is really for commercial receptacles. And so you put them somewhere, and it doesn't matter where you put them. And so first we'll start out there. And when you put them there, you'll see that it actually includes it as a separate line item, when really those receptacles should belong in this dwelling unit load, the dwelling unit lighting load. So the way that you tell the software that that's what's happening is in circuiting, there is the general lighting circuit. And we want to change that from no to yes. What this means is that whatever on this circuit is a general lighting device, either a receptacle or an actual light or whatever. And so don't also include this in the feeder and service calculation. So basically ignore this circuit because it's included in the watts per square foot lighting power density here for the area calculation. So if we set that to yes and update this panel schedule, we now have that receptacle listed here. So it's in the circuit, but it's not listed down here because it's included in this 3 watts per square foot. That's how you do that, and that's the key, is mostly you need to go into that circuit and set it to be a general lighting circuit. And you want to do that basically for your receptacles and your light fixtures. If you do have a small appliance or a laundry circuit, those go into that total, but they shouldn't be set as general lighting circuits. So if I set this to 1.5 kVA, and I'll actually label it, so this is a small appliance, that's now going to be listed here and included in this diversity factor. So we've got the 3 kVA of lighting, 1.5 of small appliances, 4.5 total. So you don't want to set that one as a general lighting circuit because it's actually a small appliance circuit, and so it wants to be included. If we set it as a general lighting circuit, then it would just be completely ignored. There's one more thing I did want to mention. When you do that, you then end up with a disconnect between your total load and the load being listed for each circuit, because we have this 3 kVA of lighting load, but it's not actually circuited anywhere on here. And then we've got this 0.18 receptacle load, which isn't in this number either. So when you are doing these dwelling unit calculations, because of the way they work, the circuit level is a little different from the feeder level. Things don't match up. And that's just because there's some inconsistencies with how these are being viewed. And so depending on what level you're looking at it, you're going to have different numbers. So if you start trying to add up these numbers here to get to this number here, they're not going to match. So you just have to be aware of that. We're trying our best to give you good and useful numbers, but when you don't actually have things circuited, we can't tell you what the total connected kVA by phase is, for example. The next question was related to motor diversity. I had a customer who wanted to add a diversity factor to his motors. He had 30 motors, and not all of them were going to be running at the same time. And so he wanted to have the software account for that. And the way that you do that is with the diverse demand factor load type. So rather than specifying them as motors, you specify them as diverse. So if we go to create a piece of equipment, we have the load type, we've got the motor options, and then we also have down here the diverse option. This basically lets you set any demand factor you want. So for something like a motor that's not always going to be running, where you know there's going to be diversity, this is the way you specify it. So we'll put some load on there, but then we can actually say, okay, a 50% demand factor. And I'll copy that. So we got 3 of those. And we will circuit those, make a new panel. So they just end up down here as diverse. It's not going to be able to see any of them as the largest motor. So if you are doing this, you probably want to take one of them and actually specify it as the largest motor. Or basically it's a single motor, and then it'll figure out that it's the largest because it's the only one. Basically we have our 1 kVA of motors at 100%. We have our diverse motors here, and then we have the largest motor being included. That's the simplest way to do it. You also could create a custom load type. So if we go into options and go create a new load type, because you have 2 custom load types you can add. We'll call this one diverse motor, and this will be, we'll just fix it. Say we know that we want these to be 0.6. And now I can modify those 2 motors that are on the diverse to use that new diverse motor load type. Basically all this is going to do is it's going to give it a different label on the panel schedule. So if you do want to label it differently than just saying diverse, because that's not giving you all that much information, the plan reviewer might question it. If you say diverse motor, then they know what they're talking. Oh, that's what you mean there. So those are all your diverse motors. And I grabbed the wrong thing. I meant to leave 1 on the motor, but it's still on the diverse, so don't worry about that. One more question for today, and that was related to one-line diagrams. Customer had a panel that they wanted to have be dashed. They wanted the rest of their stuff in their one-line diagram to be solid lines, but they wanted one certain panel to have a dashed line around it. So I'll throw in my one-line diagram here. So basically they want this line here to be a dashed line. So I can come in here and I can turn on my properties, and I can change the line type to be a dashed line, and it'll show up dashed. But when we update the one-line diagram, it undoes that. It sets everything back to solid for you, which is really frustrating because you're trying to get it to be dashed. So the way that you do that is that you actually need to create a new layer system that's going to be a dashed layer system for this. So we'll go ahead and go into the layers command. I'm going to create a new system. We'll call it dashed. It's going to be based on the new system. So all the layers are going to kind of be set the same to start with. We'll go over here to our layer key, and for our one-line diagram, for one-line panels, because that's a panel, we need to have a new layer. So I'm going to create a new layer, en one-line dashed. And we'll use that new layer for our panels. And we will set it to use a different line type. And now we will take this piece of equipment, this panel here, change the layer system to use that new dashed system. And now when we update the one-line diagram, it's going to use that automatically for us. So it's a different color and it's dashed. So that's the proper way to get a dashed box. Basically, you need a new layer system, get the layer system defined properly, assign it to the panel, and then you can have different graphics. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.